integration. What can we do in this mode? We can find definite integrals. Definite integrals are integration within the limits. We can find area under the curves, and we can find the integration of algebraic, trigonometric, exponential and logarithmic functions. So let's say you are told to find the area of the shaded region of this particular question on your screen. So if you note, the equation is f of x is x, x plus 2 and x minus 2, and we need to find the area under the curve between the limits minus 1 and 0 and 1. My advice to all students, to all participants is, when you are applying integration to find the area under the curve, it is always advisable to break this into two different parts. Minus 1 till 0 should be a separate part and 0 to 1 should be a separate part, so that the chances of errors are minimized. So please check. I will press this button. For differentiation I was using shift and this button. For integration I will directly use this button. So I have to write the equation, which is x bracket open x plus 2 bracket close, another bracket open, x minus 2 bracket close. I will scroll back, I will scroll down. The lower limit is minus 1. I will scroll up. The upper limit is 0. If I wish to write the second equation or the second function, second area of shaded region along with this, then I have to use plus, and I have to use the absolute valued functions. I hope you all remember the absolute valued function also, that everything within the absolute valued function always turns out to be positive. Always remember, area can never be negative. So if you are finding the area in a single question, in a single frame, then please remember everything below the x-axis will be a negative answer, but area cannot be negative. So we introduce the absolute valued functions, that is shift and bracket open will give you the absolute valued function. You will write the integral and you will repeat the equation x bracket open x plus 2 bracket close bracket open x minus 2 bracket close, and you will go back, scroll up. The limit is 1, the lower limit is 0, and now please ensure all the brackets that were open are closed, and you will press equals to. Your answer is 7/2 or 3.5. I hope this is clear. All I have done is I have ensured that I write the whole of this equation. First I made the limits minus 1 and 0, and then I made the limits 0 and 1. But since this was below the x-axis, I made sure that I put the absolute valued function so that there is no chance of error whatsoever. And when I press equals to, I get the desired result. I hope this is clear. Okay, I have written the equation 2 times because I have broken it into 2 parts. The first part is from minus 1 to 0. The second part is from 0 to 1. If the whole of this curve would have been, the required area would have been above the x-axis, then there would have been no need to write it twice. There is a need to write it twice because once it is above the x-axis, second time it is below the x-axis. If I will write directly from minus 1 to 1, I'll get a 0. I will not get 3.5 because the area above the x-axis minus the area below the x-axis is 0. We don't want to subtract the two areas. We need to add the two areas. Therefore, I have written the equation twice, and the second time I have also introduced the absolute valued functions. I hope this is clear. So this is what I did. I have commands available for you also. Absolute valued function was the key to the correct answer. So now find the integrals of the following. Since I promised that I will be teaching differentiation and integration of all trigonometric, algebraic, exponential and logarithmic functions, we did that for differentiation, and now it's time to do the same for integration. So the first integral is within the limits. I have x plus 1. I will close the bracket and I will scroll back. I will push the cursor up. The upper limit is 4. I will push the cursor down. The lower limit is 1 and I will press equals to and get my desired answer. I hope this is clear. Then the second part of the question is, please ensure the calculator is in radian mode whenever you are solving differentiation and integration of trigonometric functions. So I will press the integral. I will open up the bracket, sine 2x, bracket close, plus cos 3x, bracket close, and I will close the first bracket that I had opened up. Please remember, the number of brackets that you'll open up, you have to close the same number of brackets. I will scroll down, 0. I will scroll up, and that is pi. And I will press equals to. The answer is 0. So sine 2x plus cos 3x has an integral of 0 within the limits 0 and pi. I hope this is clear. Then I will press the integral. It is ln x plus 5, close the bracket, go back, scroll up, upper limit is 4, scroll down, lower limit is 1, and I'll press equals to. The result is 6.0244. And the last integral is e, that is shift ln 2x minus 5. I'll go back, I'll scroll up 7 and I'll scroll down, that is 2. Upper limit is 7, lower limit is 2. e2x minus 5. I will press equals to. The answer is 4051.358. I hope this is clear to all of you. So the first question, the question says find the slope, and in order to find the slope we need to differentiate. We are not supposed to integrate. So please read the question carefully. So find the slopes of the curve at the point where x is equals to 2. So I will press shift dy by dx 3 under root x plus 2 upon x, and the value of x is 2. So the correct answer is 0.56066. So shift dy by dx under root x, bracket open, 2x plus 1, bracket close, cube, and the value of x is 2 once again, and the result is 256.33. Question number 2 is integral of sine x, bracket close, plus cos x, bracket close, and the limits are 0 and pi, 0 and pi. and the final answer is 2. The correct answer for question number 2 part A is 2. And the last part of the last question, integral of shift ln, that is e x plus 3, and the limits are 1 and 4, and the result is 1042.035.